And our last operation that we need to deal with is a quotient between functions. And to find the derivative of a quotient, right, we would go through and do the definition of a derivative. And then it has a similar area interpretation as we saw um, the, with the products. Okay, but this one is a little bit more involved. So I'm just going to say if you want to look at it, I encourage you to look at it, but I'd say check out your textbook. They give you a wonderful explanation there. Bottom line, quotient rule. Okay, so we have, a numerator function and a denominator function. I call them highs and lows. Okay, if you take that derivative, you end up with this rule where you do g prime or g times f prime minus fg prime over g squared. Again, it's been ingrained in my brain as a little mnemonic. So you do low, d high, minus high, d low, all over low squared. Okay, again, that's just always stuck in my brain, and I use that literally every time when I have to differentiate a quotient of functions. So what I would say for this one is that this would be low, or high, and then this is low. So then when I go to do the derivative, f prime, I would do, okay, low, 2x minus 1, or 2x plus 1, d high, 3, minus high, 3x minus 1, d low, 2, all over low squared. So the 2x plus 1 all squared. And yes, you can simplify. Um, I'm going to say if you have to do anything beyond, find the derivative, like say find the slope of a tangent line, it will be in your interest to simplify. Okay, but if it is literally just differentiate as the instructions say, leave it like this. As a grader, I appreciate this version because then I can see, you know, see your thought process. Okay. G of Y, pause the video, try it on your own. And there you go. Okay. The only thing that I'll mention is that in here, right, that's a little more complicated than maybe what you anticipated because there is a product in there, right? There's an operation of multiplication. So that means we need to do, 1d2 plus 2d1 within the product rule. That could happen, okay? Be careful. Last two examples, okay? This first one, not terribly challenging. You just have to find the derivative evaluated at 2. So we want to do the derivative with respect to x of h of x over x, and then we'll evaluate it at 2. So this is going to be low d high h prime minus high d low, which is just 1, all over low squared, x squared. So then when I evaluate this at x is equal to 2, all I have to do is substitute in. So I have 2 times h prime of 2 minus h of 2 all over 4. And so then using the data that I have, I'd have 2 times 3 minus 4 all over 4. Okay. 6 minus 4 is 2 over 4, gives me 1/2 last I checked. Okay. The curve, it's a serpentine. Find the equation of a tangent line. Okay, so tangent line, I need the derivative. So to get the slope of the tangent line, right? So derivative of the serpentine, low, okay, low d high times 1 minus high d low all over low squared. So x squared plus 1. And I want to find the tangent line to the curve at this place. So then I just need to take the derivative, evaluate it when x is equal to 3. And I'm just going to say some arithmetic later. You get negative 4 over 25. Okay, so that means your tangent line is given by y minus 0.3 is equal to negative 4 over 25 times x minus 3. And I am done. Okay. Point of this video was the quotient rule. Low d high minus high d low all over low squared, or if you want to remember the g's and f's, that is perfectly okay too. So this is going to complete our introduction to basic derivative rules and shortcuts. You're welcome to use these at any point now. Have fun.